Hi, welcome to today's episode, and we are going to be talking about probabilities. In this short video, I prepared for you also 4 questions that are for you to do during your homework, just as a revision, because it's very important to revise, because that will help you put the information into your long-term memory. So basically what happens without revising, you forget. So why learn it in the first place, right? So after watching the video, here you have 4 questions to do. They're quite easy and quite fast. It's like 5 minutes of work. So please do them to practice also on your own. And as you know, everybody learns differently. So for some people, it might be watching a video. For some other person, it might be doing the exercises. So also have that in mind. All right, probability. The most important formula is this one over here. It's a fraction. On the bottom, you put the total. Let's look at the example here. So in here, we have 5 balls, 2 green ones and 3 red ones. So in total, we have 5 balls. So we'll put 5 in the bottom. And on top, we put the ones that interest us. So if those are green, it would be 2 out of 5. If it's red, 3 out of 5. So those are the probabilities. 2 over 5 and 3 over 5. Another thing is with dice. When you have only one, then the probability, for instance, hitting a 5, rolling a 5, is 1 out of 6. So we write it as a fraction. When you have 2 options, for instance, it can be 5 or 6, so you are satisfied with both those outcomes, then 2 out of 6 sides of the die satisfy you, so the probability is 2 out of 6. Alright, but what happens if you have multiple dice? For instance, if you want to roll a double 6, then on the first one you have probability of 1 out of 6, and on the second one you also have probability 1 out of 6. And in probabilities you multiply, so in here we'll be multiplying both of those to get 1 out of 36. So when you multiply the top number times the top number and bottom number times the bottom number. All right, another thing is with codes, for instance. Let's say we have a 5-digit code that we want to create. How many combinations are there? How can we choose different digits? And how many options do we have? So how many total rearrangements of the numbers? And to calculate the total probability, the total amount of different combinations, we first need to look at what numbers can we use. So let's say for this example, we can use only those numbers, 1, 7, 8, 9, and 0. So 5 different digits in total. And the code will have 4 digits. So it's a 4-digit code. And now how do we calculate it? What's the total amount of different combinations? So in the first place, we can choose 1 out of 5. And here there are 2 different types of questions. Sometimes you can use the same number twice. So for instance, we can build something like 1, 1, 1, 1, a code like this, right? So let's say we can reuse the numbers, the digits. So then we can choose 1 out of 5 digits here, 1 out of 5 digits here, 1 out of 5 here, and 1 out of 5 here. And we multiply. That's the formula. We have multiplying the probabilities. So it's 5 times 5 times 5 times 5, and that gives us 625. But what happens if we cannot reuse the numbers? Then it's very simple. In here, we have first, let's say there's the example where we cannot repeat anything. So first we have 5 digits. All right, so you can choose 1 out of 5. Then let's say we chose 1 here. So we cannot choose it again. We have only 4 numbers left, 7, 8, 9, and 0 to choose from. So it's 4 numbers. Then let's say we chose 7. So only we have 3 numbers left. So it goes down by 1. And as always in probabilities, in here we multiply. All right, and can I calculate in my head? That's 20, then it's 60, 120. So this is when you cannot repeat the numbers. So yeah, you multiply. The only thing when you add, let's say that the probability of x, there's some random event, is 2 out of 10. The probability of y, another random event, is 3 out of 10. What's the probability of x and y? Well, you add the numbers, right? Of you are satisfied with x or with y. Then you have this or this one, so you add them. All right. And now let's go back to the questions here. So first, a fair ordinary dice is rolled once. Circle the probability of rolling a 3 or a 4. So in here you have two options, 3 or a 4. What's the probability that you get one of those numbers when you roll a die? Right, another one. In here, the information that you need is that the probabilities add up to 1. The minimum probability is 0 if the chance of it happening is 0, so it will never happen. And like the maximum probability that it will always happen is 100%. And if you have like a spinner or a dice, right, the probability that you will roll something is 100%. You don't know what, but all the different outcomes, they add up to 1. So the probability in total, if you add this, it should add up to 1. In here, there's something called relative frequency, and it's really very similar to probability, and you calculated exactly the same. This is very important. You calculated the same as probability. The difference is in real life in like meaning behind it. So probability means that somebody did some mathematical calculations and is sure that the probability of something happening is this much. Let's say if we toss a perfect coin, then the probability of getting one of the sides is 50%, the other is also 50%. So somebody did an experiment, tested that, etc. But it's with like a perfect coin, not a real one, because on real one it's very close to 50%, but not exactly. But relative frequency is the opposite of like testing it with a large sample, doing experiments, calculating stuff. It's like somebody did something like in here 40 times and those are the results. So it's not like, oh, this is the probability. No, it's just somebody did something a few times and that's it. So it's not like scientific, but it's close. Probability is like, okay, that's exactly how much it is, that's exactly the probability, and relative frequency is like, okay, we did a little bit of tries, but not enough to call it probability, but we think that it's close to this. So that's the difference between relative frequency and probability. That relative frequency is not like, oh, it's 100% this number, it's just like an estimate. All right, and the last one, which of these values could represent a probability? So in here, the thing is that probability, the minimum is 0 and the maximum is 1. So the probability can be only in this range from 0 to 1. All right, so I hope this little lecture was helpful for you, and please do the 4 short exercises. And yeah, thank you for listening, and I hope this material was helpful to you. Thank you for listening. Have a great day.